let's consider the case when phi is equal to a constant a multiplied with the logarithm of r plus a new constant b. And this was the case when this was a solution in the case of a coaxial problem, which we have discussed before. R can be written as the absolute value of z, and in order now to find the harmonic conjugate of this function phi, we first recall that the principal logarithm of z is just equal to the logarithm of the absolute value of z as real part and plus I times the principal argument of z. So we now see above that we are going to multiply with a. This term is multiplied with a, so if we are multiplying on left and right side of this identity with a, we obtain that a times the principal logarithm of z is equal to a logarithm of z plus I times a argument of z. So the harmonic conjugate of this guy is just has to be a times the argument of z, because the harmonic conjugate is always a uniquely determined function, at least in the cases we are considering. This term b is not so essential, because the harmonic conjugate of a constant is just any other type of constant, so we can just ignore this in this case. Well, so now we are finding the complex potential as this phi, which we know, plus this harmonic conjugate, which we also knows. And then we just implement or substitute these expressions. Here we have the function phi, and here we have the harmonic conjugate. So we can now we can add or collect these two terms and obtain that we have a times the logarithm of z plus I times the principal argument of z. And we know that this is just the logarithm or the definition of the principal logarithm of z. And we add this constant b. In fact, b is in this case any real number, but it can also be any complex number if you like. So in our case, we know that we already knew that these equipotential lines are circles, because these lines are the lines where the function phi or the potential is constant. And due to the fact that we know the harmonic conjugate of phi, we can now find these green lines, which is the power lines, and they are 90 degrees relative to these circles. So, and we know that the argument value of z is constant when on these green lines, because these are the argument of z is just equal to the angle between this real axis and any straight line in this direction, in the angular direction.